What's up, everybody? Today we're going to be doing Thevenin equivalent exchanges for circuits. So let's look at this problem real quick. Take a moment to read it if you'd like. But what we're going to be doing is a Thevenin exchange, and we're going to be solving for Ix. So what is a Thevenin exchange exactly? So a Thevenin equivalence exchange, pretty much what you do is you take a current source and it becomes a battery source if you put it in series with the resistors. So I'll show you what that looks like in the circuit here. So we took that 24 amps and we made it a battery source. And note that 60 ohms that's in parallel in the center there is now in series with the rest of the circuit. And what I also did here, notice, is I removed the battery, and I'll show you why in a minute. But we can figure out what the voltage is there by doing Ohm's law, using Ohm's law, and we know that 24 amps is the current source times the 60 ohms resistor, and that is 1440 volts. So that's how the battery source is there. And the reason it's called Thevenin equivalence is because a 24 amp current source in parallel with 60 ohm resistor is the same thing as a 1440 volt battery. So that's where the equivalence comes from. So now what we're going to do is rewrite our circuit and include the original battery. So if you notice here, the battery, I took out the 180 volt battery, but now we're going to put it back in so we can find REQ real quick, just because we can, since these are in series. So 60 plus 120 is 180. So now we have our equivalent there, and we have our both of our batteries. Now, really cool trick with circuits. Two voltage sources in series, notice how these are in series, actually sum together. So 1440 plus 180 is 1620 volts. Awesome, right? So now we can use Ohm's law again and say I is equal to V over R, and we can find our current, which is 9 amps. Awesome. So that was Thevenin equivalent exchange. Stay tuned for Norton equivalent exchange.